Hey guys, so today we are going to be going over the Chapter 4 example problems from using your saturated refrigerant tables that we went over a little earlier this year. Just to give you guys a little bit of a refresher, you guys should have finished your book quest for Chapter 4, but most of Chapter 4, I fit most of the book quest information in these two slides. So you should have already completed those. The example problems are the big thing for Chapter 4, though, getting to know your saturation tables and how to use the information within them. Now, you guys may be wondering why I have everything up like this. It's because instead of having it in like the presentation mode, it's just because I can pull up the saturation table reference, and I'm using the study guide, which you guys will have on your CARO exam, so you need to become a little more familiar with it. Some of the numbers that we get for some of our answers might vary a little bit because they were based off of the other table that I gave you guys earlier this year. I like that table because it has a little more information than this one. Both are still really valid, and the answer shouldn't stray more than just, a couple little numbers right there. So, yeah, let's get into it. First of all, let's start out with this problem. An evaporator with a saturated temperature of 35 degrees would give an ammonia evaporator pressure of what? Okay, so we know that we are in our evaporator, and we know that, so we are in our evaporator, and we are at saturation 35. So we have our evaporator temperature at saturation. Okay, we need our evaporator pressure at saturation. Okay, this is saturation, so we can use our saturation tables. So all we have to do is find the temperature that relates to the pressure. Okay, the pressure that relates to the temperature at 35 degrees. So all we have to do is pull up our table, scroll through it, and find, this is an ammonia, so make sure that you guys pay attention up here at the top, okay, to make sure it says ammonia and you're not looking at HCFC22, and vice versa, because both refrigerants will be referenced on the exam. So ammonia, look for 35. Let's see, we got that right here, it looks like. We have 35 degrees Fahrenheit. And this column, let me see if you guys can see it. It won't let me scroll up at the pen. Oh, there it will. Okay, is PSIG. Okay, make sure you use the correct units. Most of the time we'll be referring to PSIG. We use PSIA for compression ratio. Okay, so at 35 degrees saturation, we would be at 51.37 PSIG. So 51.37 PSIG. Now let's check that. Bam. That's our answer. Okay, let's move on to another problem. This one, instead of our evaporator, we are in our condenser. Okay, so at 95 degrees condensing temperature, an ammonia system's condensing pressure should be. Okay, so since we are condensing, we are at saturation. Okay, condensing, changing phase, saturation. It's going to happen at a constant temperature and pressure. So at 95 degrees Fahrenheit, what would our pressure be in PSIG? So all we have to do is check our table and see what we got here. 95. Scroll down to 95. Make sure we're on ammonia. We are. Okay. And at 95 degrees, we should be at 180.65 PSIG. 0.65. There we go. PSIG. So that should be our answer. Is that correct? Yes. Look at that. Too good. Okay, let's do another example problem. So this one's actually going to take a little bit more math. So, how many cubic feet would 250 pounds of liquid ammonia, it's important to specify whether or not it's liquid or vapor ammonia, occupy at 90 degrees Fahrenheit? All right, so we are looking for our answer in cubic feet, okay, and we are given pounds. Okay, so if we try and follow our units and we set up that we are given pounds, okay, and we're trying to find cubic feet, okay, then we would want an equation with pounds on the bottom, okay, so that we can cancel them out. So let's look, and we know that we're operating at 90 degrees Fahrenheit, so let's go check our saturation table for this ammonia. Yep, our saturation table for ammonia, and see what we got at 90 degrees. Oh, I was still right there. Awesome. All right, and we're looking for a unit in cubic foot per pound. Now, the unit for cubic foot per pound is going to be your specific volume, okay? And you see we have, right here, we have the specific volume of liquid and the specific volume of vapor, all right? Now, it's important that we have made that distinction. There we go. Okay, important that we made that distinction because we are working with liquid. So this one doesn't matter. So 90 degrees Fahrenheit, we follow that over all the way to our specific volume of liquid column in cubic foot per pound, and it's 0.0270. Okay, so now all we have to do is fill in our equation here. So we start out with 250 pounds of liquid ammonia, right? And for every pound of liquid ammonia, it takes up 0.0270 cubic foot per pound. Okay, so now we do out our math, pounds crosses out, we're left with cubic feet, which is what we wanted, and we just multiply 250 times 0.0270. So 250 times 0.0270, 6.75. So our answer is going to be 6.75 cubic feet. That is how much space. So if we had 250 pounds of liquid ammonia, okay, we put it on a scale, right, and it read 250 pounds, then the volume of the box it would take up would be 6.75 cubic feet. Okay, if it was operating at 90, if that box, the ammonia in that box was operating at 90 degrees Fahrenheit. Okay, now let's try the next problem. Are you still recording? Let me see if it's still recording. Oh, there it is. Alright, so just totally please ignore that. I'll see if I can cut it out. Apparently the little thing will disappear sometimes, and it's very hard to find. This is free recording software, so I'm going to use it. Alright, so, continuing with the thing that we were doing. 6.75 cubic feet, that's what we got? Bam, that's the answer. Next problem. Okay, so this one says, how much would 600 cubic feet of ammonia vapor at 60 degrees Fahrenheit weigh? Okay, so we're looking for how much it would weigh in pounds, right? That's the unit we use. So in the last problem, okay, up here, we were converting pounds to cubic feet. Okay, so in this, we're going to be converting cubic feet to pounds. Okay, same thing, just backwards. So we're going to start out with our 600 cubic feet. Okay, And we are looking to cancel out cubic feet, so we're going to put that in the bottom. And the unit we're looking for is going to be pounds. Okay, so we need pounds per cubic feet of ammonia vapor at 60 degrees Fahrenheit. Well, let's look at our saturation table. And oh, look at that. While it was paused, I already scrolled back to this correct page. Okay, so pounds per cubic feet is going to be our density. Okay, and we are working with vapor, like it said in the problem. So not density of liquid, working with density of vapor, pounds per cubic feet. And we are looking at 60 degrees. So at 60 degrees, our density of ammonia vapor is 0.3627. Okay, so fill that in, 0.3, I can't write, 3627 pounds per cubic foot. All right, so we know that cubic feet cancels out. We're left with pounds, which is what we were looking for. So 600 times 0.3627. All right, let's, wrong one. Multiply that out. So 600 times 0.3627 is 217.62. 217.62 pounds. Okay, so if we had a box, right, and the volume of that box, it was at 60 degrees Fahrenheit. Okay, it was full of ammonia vapor, right, and that box had a volume of 600 cubic feet. Okay, and you went to go pick it up, it would weigh 217.62 pounds. Okay. Now, if you look down here on this page, it says our answer is 218.1 pounds. That's because when I first made these PowerPoints, I used the old table. So like I said, the numbers are just slightly off, right? But if you go to pick up something that's 217.62 pounds, okay, and you go to pick something up that's 218.1 pounds, it's not even a 1 pound difference, okay? Not even a 1 pound difference. All right, you're not gonna be able to notice. But yeah. All right, so I'm gonna pause the video right now because it only lets me record 15 minutes at a time, and I'm at like 12:30, and continue the rest of the problems.